Welcome to the Agentic AI series, where we build one agent piece by piece across its whole architecture. In this demo, we cover the run loop, memory and state, and orchestration. This is the big one, because a real agent is more than a single call, it's a process, and that process needs three things. First, the run loop, or runtime, the engine that calls the model, runs its tools, looks at the result, and goes around again until the job is actually done, instead of stopping after one shot. Second, memory and state, the context the agent carries within a run and across runs, so it can build on what it already found instead of starting from zero every time. And third, orchestration, coordinating several specialized agents and steps, one to do the work, one to evaluate it, one to fix it, into a single workflow that drives toward a result. Put those together and you stop having a clever one-liner and start having a system. It loops, it remembers, and it coordinates. This is also why flow is the deepest part of the series. There's simply more machinery here than anywhere else, and it's the part that most looks like production. And that's the real lesson most people miss. An agent isn't one prompt in and one perfect answer out. A single model call is powerful but fallible, so you surround it several specialized agents that write, evaluate, and rewrite, the loop, the guardrails and checks, the memory, the tools, and even a human in the loop rating the result so the system keeps learning. It was never really about the code, AI can write that now. It's about understanding the architecture, that a hard problem needs a coordinated system of agents. You don't point one agent at a difficult problem and count on magic. You build a system. Welcome to Part 2, Control Flow and Orchestration. In Part 1 we met the workflow. Write, evaluate, rewrite, and loop until it's good. Now we look at how that loop is actually wired. It's the same workflow we built in Part 1, with the same 7 phases: gather, evaluate, select, rewrite, execute, remember, and translate, and the same 4 agents: the writer, the evaluator, the rewriter, and the error translator. This time, let's explore the details of the plumbing. There's more than one way to connect those phases, and the choice changes how the whole thing reads. One workflow, 3 ways to wire it, different control flow. The Microsoft Agent Framework gives us 2. First, an Orchestrator class with plain for loops. Second, a workflow graph of executors, which is a DAG, a directed acyclic graph. That just means the arrows only ever point forward, never backward to an earlier step. Then LangGraph gives us a third, a StateGraph with conditional edges. This one is a true cycle, so unlike the DAG, it is allowed to loop an arrow straight back to an earlier step. The logic is identical in all 3. Only the wiring changes. Here are the 3 side by side. To keep the picture simple, we collapse the 7 phases down to 4 main stages: gather, evaluate, rewrite, and execute, stacked in the same order every time. Now look at the rewrite step, because that is the only thing that moves. In the Microsoft Orchestrator, a plain for loop carries the winner back up to be rewritten and re-evaluated. In the Microsoft workflow, that same rewrite and evaluate loop still runs, but it is tucked inside a single phase, so you don't see it in the wiring. In LangGraph, a conditional edge loops it back out in the open. Same loop, 3 different shapes. If you're enjoying this, please like and subscribe so the next video finds you. Now let's keep going. First, the Orchestrator. This is just ordinary Python. Gather the candidates, evaluate them, pick a winner. Then a for loop. While the score is below threshold, hand it to the rewriter and try again, up to a maximum number of rewrites. Finally, execute. The loop is right there in the code. Easy to read, easy to step through. Next, the workflow. Same phases, but now we build a graph. Add an edge from phase 1 to phase 2, 2 to 3, and so on, all the way to the end. There's a catch. A workflow is a DAG, the forward-only graph we just met. It can't naturally point an edge backward. So the rewrite loop has to hide inside phase 4. Inside that one phase it still does the full job, rewrite, then reevaluate, then check the score, and repeat. The loop still happens. You just can't see it in the wiring. Finally, LangGraph. Here the loop is a first-class citizen. We add a conditional edge off the rewrite node. A little function checks, is the score still below threshold? If true, route back to rewrite, and loop. If false, move on to execute. The graph itself shows the loop. There's no separate orchestrator here, because the graph is the orchestration. So why does the shape matter? Because the wiring decides how visible your loop is. In the orchestrator, the loop is ordinary Python, plain to see and easy to step through. In the workflow, it's a forward-only DAG, so the loop hides inside a phase. In LangGraph, the loop is a real edge, and the graph shows it looping back. Pick the model that works for you. Next part, we give this workflow a memory.
Thank you for spending time with us. Like and subscribe. Stay sharp, stay Azurite. See you in the next one.